Hello, and welcome to an introduction to role-based access control. A little about myself. My name is Lance Romai. I've spent a number of years supporting Aerohive, Aruba, and Ruckus wireless networks. I also support switching infrastructure, both campus and data center. I hold certifications from several vendors, as well as the CWNP certifications of the CWNA, CWSP, CWAP, and CWDP.
Okay, so what are we going to be talking about today? Well, today we're going to be talking about the bare bones of what role-based access control is. Before we go forward, you should be at least a little familiar with 802.1x and Radius. Now, it's okay if you don't know anything about RBAC. This is an introduction into that topic. This video is not meant to be a design guide for your particular controller or device or your particular environment. Every situation is going to be unique and every NAC is going to be unique as well. Okay, we're going to be talking about what RBAC is, and we're also going to be talking about why you need it. And what we're going to do, we're going to be setting up a controller using an internal database to authenticate some users and to assign them into roles. All right, so let's begin. So what is RBAC? What is role-based access control? Well, it's kind of the way it sounds. It's access based on particular roles. Now, how those roles are attained, well, that's taken from something that you have. RBAC takes something that you present to in the authentication process, and it uses that to grant or deny access. When access is granted, different levels of restrictions or access can be granted. Now, this is based on layer 2 or layer 3 restrictions, and you can even go up the OSI layer to layers 4 and through 7 through the use of stateful firewall rules. Most RBAC makes use of radius or domain attributes. For instance, the member of variable is a common one that is used. Now, it uses these to place users in particular roles. Those roles in turn contain rules that allow or deny access. Now, through the use of RBAC, an administrator can extend services and features to devices or users based on things that are presented in the authentication process. You can also use RBAC when authenticating against LDAP or an external server, but the features are more limited there. Usually it's done through radius attributes. In most cases, you don't actually need to, in some cases, you don't actually need to use 802.1x for RBAC. For instance, say a wireless barcode scanner. Um, if those wireless barcode scanners are 802.1x unaware, you can use WPA2 PSK, and then you can set up an access rule to allow, for instance, only the MAC OUI of that scanner manufacturer and grant access to just the inventory management system. And then you segment those scanners into that management system and don't allow them to go anywhere else. So that thus you're containing them. Okay, so why do you need role-based access control? Well, one of the number one reasons is security. Enhanced wired to wireless network security. Security breaches can come from the inside of your organization just as easily as an intruder from the outside. In fact, many of them do. They come from employees that are doing it unintentionally. So, as best practice, it's a good idea to give your employees access to only the information that they need to do their job. For instance, someone in sales would have no need to access information and sensitive financial information from the accounting department, for instance. So you would not want to give that user that role, that particular access. So the best thing to do here is to define a role for that salesperson or that salesperson group, and to keep that group segmented away from the accounting team or the sensitive financial departments. Okay, another good reason why you would need role-based access control is the ability to group users by attributes such as departments, groups, locations, etc. It offers a more granular control. There's also less user administrative overhead. Role-based access control allows for administrative simplicity. By assigning users to groups and roles instead of modifying user permissions on a per user basis, there is no need for extra paperwork and processes with new employees and when employees need to change roles. This process is meant to be highly efficient. User tracking. Role-based access control offers increased visibility over what users access and where. Regulatory compliance. Role-based access control allows for a more efficient management of how data is accessed. Increased visibility and tracking allows companies and institutions to comply more easily and efficiently with government regulations, such as in organizations such as healthcare or finance. Much easier for security compliance auditing when you're defining users and profile groups rather than individually. And finally, in the wireless networking world, role-based access control allows for simplicity in the wireless networking design. Role-based access control allows for decreasing 802.11 management overhead on the wireless medium. So instead of a network broadcasting for each user group, you can have multiple users access a single wireless network and then have them be segmented accordingly. We'll be demonstrating this today. For instance, on the screen that you'll see a single SSID, and then you have users in the admin, the IT, and the HCR group connected into that same SSID. Okay, let's move on to the demonstration portion. What we'll be doing here is using role-based access control. We'll be demoing 3 separate users, and those 3 users will get into 3 different roles. They will all be connecting to a single SSID, and they will be going into 3 different subnets. For this, I'm using an Aruba 7210 controller with a policy enforcement license. We'll be using the internal database of the controller for our users. Here we have sales, marketing, and contractor. Each of these will be going into a separate VLAN and into a separate role, which will put them into a separate VLAN and thus a separate subnet. There will be a couple ACLs to prevent them from going into other locations as well. So let's go ahead and take a look at the VLANs here. We have VLAN 10 for sales, VLAN 20 for marketing, and VLAN 30 for contractors. Looking at our IP configuration, we have .10 for sales, .20 for marketing, and .30 for contractors. And our DHCP servers are set up accordingly as well. Let's take a look at once again at our 3 users. We'll see that, for instance, a sales person here with the gets into the sales role. Marketing gets into the marketing role. And a contractor gets to the contracting role. Let's take a look at the roles and what they actually mean here. Starting with the sales role, we can see that the sales role gets VLAN 10. It also has an ACL in here to restrict it from accessing marketing. And then last, it has an allow all just to simplify the configuration for the sake of this lab. Marketing, same deal. Different VLAN, VLAN 20. It has a restricted an ACL here to restrict it from getting into the sales subnet, and then an allow all for the sake of simplicity. And then we have a contractor role. It gets VLAN 30, and we do have a restrict option here to prevent it from getting into the sales or marketing subnets, and then an allow all for simplicity. Here we have a machine in my lab that I'm RDPing to. We're going to use this for testing. I also have a Wireshark that is going to be monitoring the authentication, authorization, and the EAT process. First thing we're going to do is try connecting using the sales credentials. Okay, as you can see here, we have the authentication association and the request identity process. Those familiar with the EAP exchange are going to be familiar with this request identity here. And those are familiar with the from Wireless Association are going to be familiar with the authentication and association process. So now we have the controller just requesting that identity from the client. Let's go ahead and give it to them. Hopefully I typed that in correctly. We'll find out shortly. There we go. It's success. This is the tunnel where the inner credentials are being shared. And here's the tunnel being built right here. Server sends its certificate. Like I said, those familiar with the exchange process will know what that's like. Okay, let's go ahead and just take a look at what our IP address is here. All right, we are in the sales subnets. We got 10.2. Take a look at our controller. Take a look at our clients. We do have the username sales, IP address, and the role. Let's go ahead and try again for marketing. And then again, you see the process here. And a success. We can see that marketing is in there now. And looks like we have the marketing subnet as well. Try this once again for contractors. Okay. There's the EAP exchange process, and we have our success. Let's do an IP config. We are in the correct subnet. Let's check out our controller. And there you can see we have our controller is connected and in the contractor role. I'm sorry, our contractor is connected and in the contractor role. And that concludes the demonstration of role-based access control. I certainly hope this provides a reasonable explanation for you. For further exploration, I would recommend the following resources. There's David Coleman's Understanding ArubaOS. That would be a pretty good explanation of the controller that I used for this particular demonstration. It doesn't go too much into RBAC though. There's David Coleman, David Westcott's, and Brian Harkin's CWSP study guide. Excellent resource not only for security-based access, but for obtaining that certification as well. You can do Aruba OS guides and also just go ahead and explore various NAC documents, network access control documentation for, say, like Aruba ClearPass or Cisco ICE. You'll certain to get a wealth of information from that documentation. I will include some resources in the links on this video. And again, thank you very much for for watching.